welcome to WASA Distance Education. This is MBF3C, Grade 11 College Prep Math. I'm Pete, I'm your teacher, and welcome to the last class of week number 2 of our course. Now, just a quick announcement here, and I'll mention it again, but Monday is a holiday, it's a family day, so there is no class Monday, okay? And so we'll just resume our classes after today. We'll resume our classes on Tuesday. Now, you'll still get the normal number of classes that you're supposed to get. It's just we build these holidays into our schedule. So what we did yesterday, we've just sort of wrapped up the exponent laws. And we have just one more fairly short lesson topic in Unit 1, so we'll actually wrap up Unit 1 today. Okay, now if you have a, let's see here, so let's take a look at Lesson 4, the exponent laws. I just want to make sure that we kind of got that nicely tidied away. One thing I sort of notice about that is that the course material doesn't really show you some of those really tough cases that they have in the support questions and in the key questions. So let's take a look at some of those and before we go on to to Lesson 5. Okay. So you will need for Tuesday, you'll need your Unit 2. So that's something, if you can grab your Unit 2 today or tomorrow, then that'll be good. Because remember, most of the DECs will probably be closed. The learning centers will probably be closed on Monday as well. Okay. So here we are. We're on page 28, and I just want to show you some of these questions because they really don't show some of these real monster questions in the course material, like 2F and 2D. I'm not sure if I'll do them all, but let's just take a look at 2D to give you an idea of how we might do that. Okay. So it's asking us to simplify, which just means to expand it out, use the exponent laws. And let's take a look at that. I'm going to just rewrite it on a blank sheet. So that's support question 2, and then it's part D. Okay, so let's see. We have 3ab squared c, and then all of that is to the power 2. So the first question you have to ask yourself is, what law am I going to apply here? Remember that we have 3 laws and then a couple of special cases, right? The 3 laws are multiplying powers. So when you have the same base and you're multiplying 2 numbers with the same power, with the same base, powers. Dividing powers and power to a power. Okay. So what this actually is power to a power. Okay. If I draw in the 1 exponents where they aren't there, now it should become clear. Okay. So when we're going to rewrite this, then we just rewrite it using the power to a power. So I have 3 and I have 1 times 2 right there. Okay, that's not going to change anything, but just show you where we get all this. We have A, and I also have 1 times 2. Then we have B, and that one's a little, we already had a 2 there, and we're going to multiply it by 2. And then we had C, and it's 1 times 2. Okay, there you go. So that's the expansion of that. And now it's just a matter of going back through. And what we have is 3 to the power 2, which we could write as 9. Okay, we have a to the power 2, because 1 times 2 is 2, so a squared. We have b to the power 4, and we have c to the power 2. Okay, so that's how that sort of expands out. I wrote it all spaced out like that, but it actually should be kind of more compact, just like it was originally written. Well, if we take a look at what actually happened here, the way it wound up, really If I wanted to take a little shortcut, I could just write this out without going through that intermediate step and say, all right, 3 squared is 9, a squared is a squared, b to the power 2 times 2 is b to the power 4, and c um, squared is, well, c squared. So you see, I could take a little shortcut there and just do it without that intermediate step. And it's entirely up to you how you want to do it. Being able to do it this way that I just showed you, I think it comes from a bit of experience working with these. And it kind of shows you that's a very key part of algebra as you advance in your math knowledge, right? As you move on. You're going to teach some grade 12 version of this. You're going to take a college prep. You'll be working with exponents quite a bit. So that's how we work on that. D, and let's take a look at F. Well, we could really do the same thing for F. So I'm just going to back up. And what we have here, you'll see that we have a power to a power right there. So I would deal with that one first, and then you just have two multiplications. Basically, once you fix that, distribute that 2 within the brackets, then it's just two quantities multiplied together. And so you'll just pair up the ones, for example, well, I'll try it a little bit. So it's going to be 49, right? So 7 squared times m to the power 4. Now, times n to the power negative 10. Okay. And then minus 3m to the 4, n to the 8. Okay, over something or other. I'm not going to write that down. And so now it's a matter of combining. You're just going to multiply things out, right? So negative 3 times 49 is, well, whatever that is. m to the 4 times m to the 4. Now, that's going to be m to the 4 plus 4, which is 8. Okay, I guess I better figure out what minus 49 to the times minus 3 is. 49 times, whoops, negative 3. Oh. Okay, so negative 147. So negative 147, and then it's going to be m to the 4 plus 4, you see, and then it's going to be n to the minus 10 plus 8. Okay, so that's that top number, that's the numerator. And then you would work out the m and the n. That's your numerator, and then you'd go and do the same thing on the denominator. Okay, I hope that was clear. Let me know if you want to see that whole thing done. I just kind of gave you a sketch of how I do the first little bit of it. Okay. All right, so let's take a look at lesson 5 then. And lesson 5, simple exponential equations. So we're going to look at another class of equations. So far we've been looking at parabolas, and just as a refresher, the parabola kind of usually looks something like this. This is your x, this is your y. And there's another class of equations that looks a little bit like half of a parabola. It's a slightly different shape, and they're called exponential equations. And again, they show up a lot in science, in medicine especially, quite a bit, and in other areas of business. Okay, so you'll be working with those probably, depending on what you end up doing with your college prep math class. Okay. And that's really the thing, right? We don't really know, so we're going to show you a bunch of stuff. And then if you want to be a veterinary assistant, you'll go study that, and then whatever math that you're going to use regularly will be a part of your program. Okay, so it'll get really specific the further you get. So this is exponential functions, and this should be on page. Tell you what page we're on. Unit 1, page 30. So this is what an exponential function looks like. It's the form y equals a, which is some constant, times a base b, which is a number, to a variable. So be careful there. An exponential function has a variable as an exponent. Okay. Now, the ones that we're going to look at have the b, the base is just a number. It says any positive number except 1. And the reason for that, if we take 1 to any power, it just ends up being 1. So it's not an exponential function. It's actually a line. And then a is a non-zero number. So a is just some number in front of the base. Okay, it could be like a 5 or something like that. Okay, it can't be 0 because then the whole thing would be, y would be equal to 0. All right. So it says here that when the base is greater than 1, the graph will go up and to the right. So I don't think they actually have a picture of it on this page. So it'll go up and to the right. Okay, so there you go. This is your x. This is your y. Okay. Now, an interesting thing is it crosses the y-axis at 1. Just yeah, at 0, 1. And there is no x-intercept because this tail here just never actually quite reaches the x-axis. Okay. Now, when our value of b is less than 0 and greater than 0 and less than 1, so less than 1 basically, the graph is going to go down and to the right. So what that's going to look like, let's see if I can draw this. Okay, so the b, so this is our x, this is our y, and so the exponential decay is going to look something like that. Okay, and this is still 1 on the y-axis. Okay, so this is for b. Okay, for b between 0 and 1. Okay, and this one is for b greater than 1. Okay, if b is equal to 1, then we're going to not have a exponential function. It'll just be a line, straight line. Okay, so this is exponential growth. It's called exponential growth. Okay, if you're a fan of zombie movies, they very often at the beginning of the movie they'll show you exponential growth of the zombies as people get infected or whatever. So yeah, exponential growth is science fiction really loves that kind of thing. The movie The Andromeda Strain and all these science fiction movies where there's a big catastrophe, they always like exponential growth because it makes things happen really fast in the movie. Okay, and of course it will happen in real life. It'll happen like if say in a patient that has some sort of infection. If you're a veterinary assistant, you'll be measuring some condition that the patient has. And then you try to treat it. You try and stop that exponential growth. This, where it goes down and to the right, it's called exponential decay. Okay, and there's a lot of natural processes that have exponential decay, and even so it sort of happens quite a bit. Radioactivity is probably one of them. Even something like in the business world, the number of people buying your product, right? It starts out really high, and then over time it goes down to almost but not quite nothing, right? So people, I'm sure there's people still buying iPad 1s or something like that, but it probably looks like an exponential decay, where the only people left buying them at the end are the ones that are just replacing one they already have. Okay, so the key here then is that your exponential function is going to have a variable. It doesn't have to be x, it can be anything, but it's going to have a variable in the exponent, not the base, not the coefficient, okay, which in this case would be a. They're just calling it a non-zero number, okay, but it'll have a number, sorry, a variable. Don't say number. It'll have a number. Don't say number. It'll have a variable in the exponent. Okay, I hope I was clear there. All right, yeah. So you see, try to keep your eyes on the destination, not where you don't want to go. So the example here, it says complete a table of values using values of x between -3 and 3 inclusive for the exponential functions. Okay, so it's going to ask you to graph these. It's going to ask you to make a table of values. Now, you know, if I was given something like this, I'd probably be inclined to use Excel, a spreadsheet program to make this graph. And a lot of people, a lot of high school students that are studying this actually have graphing calculators. We're not quite so lucky, so we need to do this. So let's see how we go about doing it. Now, and you know, they have the solutions there, but there is quite a bit of value in working these out. Yeah, maybe working at least one of them out. Okay. So I'm just going to switch screens here, and you're on page 30 of Unit 1. Now, so the function is y equals 2 to the power x, and we're going to just do x and y. It's kind of traditional to write the actual function in there. Now, when you're making a table of values, you typically choose something that's convenient. If there's a fraction in the equation, you'll pick something that's a multiple of the fraction. So you don't have to go by 1 unit. You could go by -1, 0. Yeah, you don't have to go just, you know, go up by 1 unit. You can go by 2, you can go by 5s. What you want to do is get a sense of the shape of the graph. Okay. But this is pretty typical. If someone asks you to graph an equation, you'll graph a few points. You don't even have to, this is, what is it, 7 points? You don't even necessarily have to do all 7. I think you'll be able to find the shape of it if you graph fewer. But what they want you to see is where it ends up being y equal 1, I think is probably one of the things they want you to see here. So let's just give this a try then. So we're going to substitute our x value into the equation. So I'll just change to blue here, and we'll say y equals 2 to the power -3. There you go. Okay. Okay, well, 2 to the power -3. Now, that's kind of interesting because we could plug that into our calculators, but if we remember our exponent laws from the last chapter, 2 to the -3 is actually equal to 1 over 2 to the power 3, right? Well, 2 to the power 3 is 2 times 2 times 2. You could do that on your calculator, but 2 times 2 is 4, and 4 times 2 is 8. So this whole thing is equal to 1 over 8. Okay. There you go, 1 over 8. Now, you know, unless you have some good reason to turn that into a decimal, you probably can just leave it that way. You know, if you go to graph it and then you need it into a decimal form, you could just divide 1 by 8. But if you come up with a fraction at this level of mathematics, chances are you really don't need to go any further. Okay. All right, well, let's try the next one. So we have y equals 2 to the power -2 equals, now, can we take a shortcut here? Oh, yeah, absolutely, we can take a shortcut. Okay, so how did I get my 1 over 4? Well, I know that the reciprocal of 2 to the power negative 2 is going to be 1 over 2 to the power 2, right? And 2 to the power 2 is 4, right? It's just 2 times 2. So 2 to the power negative 1 is just 1 over 2. Okay. Now, if you're not sure where the 1 went, it really is 1 over 2 to the power 1, but keep in mind that we don't write an exponent. Generally, we don't write an exponent as positive 1. Because if we did that, we'd be writing it literally everywhere. Every number that doesn't have an exponent is assumed to be a power of positive 1. Every single number. So we'd be writing that all over the place. Don't want to do that. So that's why I just wrote 1 over 2. All right, well, let's try this one. Y equals 2 to the power 0 equals, aha. Now, this is one of those special cases from back in our exponent laws. If you'll remember, it's a 0 exponent. Okay. And anything, and you can try it on your calculator, and the answer should be 1. Any base to the power 0 should be 1, with the exception of 0 itself. So 0 to the power of 0 is undefined. We don't even talk about it. Okay? It's just undefined. Okay, 0 to the power 0. It's one of those things like trying to divide by 0. Just doesn't happen. Okay. Okay, well, let's try the next one then. So y equals 2 to the power 1, which is just 2. There you go. Y equals 2 to the power 2. Oh, this is going to be a little easier. And then y equals 2 to the power 3, which is just, what's it going to be, 8. Okay, so notice there's an interesting symmetry here, isn't there? Right? And we'll actually see that no matter what numbers we pick, the negative numbers will be 1 over the positive values, which makes sense because that's one of our rules of one of our exponent laws. It's the one with the negative exponents. To make it positive, you just take the reciprocal. Okay. All right, well, now we're ready to graph this thing here. And what I would normally do here is move on to a sheet of, I guess I could do that. I'd get some graph paper. Actually, let's see if I have some in here. You never know. I might have some graph paper. I'm gonna have to search here. Grid. Whoops. Okay. Oh, we're getting there. Look at that. Aha! I think that's gonna work. Okay. So this is my. Okay, if I can get control of my pen back here, then this will be great. All right. Okay. There we are. Okay, so just to simplify things, I'm going to actually, let's see. Okay, send it back. And then I just want to lock this in place. Just a little bit of housekeeping. So now I think that I can erase this stuff. Yeah, there you go. And so we have our grid. All right. X, that's our X, that's our Y. And so we're going to just graph this thing. Now we're going from, we just need 3, 1, 2, 3. What I'm going to do is I'm going to use, whoops. Okay, didn't mean to do that. I'm going to use 2 squares per unit. I could have even used 3, but this'll work. So there's my 1, there's my 2, there's my 3. I just there's no need to scrunch everything down into just like using 1 square per unit if you have room. So I always recommend you make these things as big as possible. Use as much room as you can. Now, I could have used 3 squares per unit, but then that's a little awkward to graph on because I have multiples of fractions of 2 in my data, so that's a little more awkward. All right, so let's try graphing this thing. So when So when x is 0, so this is my x value is 0, y is equal to 1. So there's a point right there. Okay. And when x is 1, my y value is 2. So it's right there. I can't be all that accurate just because of the technology I'm using here. But basically, I'm trying to plot them on the lines. You'll be able to do much better. What happens is the touch screen is not exactly lined up with the um, display, so it's off just a little wee bit. Okay. When x is 2, then y is 4, and so this gives us. Oh, and there was a 4 there. 4. Oh, and there's an 8 too. Well, I guess I won't be able to plot that last one. So that's what it looks like on the positive side. Now on the negative side, when x is -1, which is going to be here, -1, -2, -3. So when y is x is -1, y is 1/2. So the 1/2, we actually have a point for it. It's right there. Okay. And when it's -2, it's a quarter, which we actually also have a point for. There you go. And when it's -3, it's going to be 1/8, which again is going to be just above the line. Now notice that that fraction is going to get smaller and smaller and smaller, but it's never going to reach 0. Okay, it's just going to keep going. No matter how big we make the x values, it's never actually going to be 0. So now that I have that, I'm going to take a different color, and I'm going to join these points in a smooth curve. Okay. And there you go. So it looks something like that. Okay. And now I can y equals 2 to the power x. That's a typical way of writing this thing out. Okay. So when you're joining points like that in a smooth curve, what I suggest you do is just practice doing that. And that's really all it is, just practice. It certainly would be a mistake to join them with a ruler because it's a curve. It's not a straight line at all. So that is an example of exponential growth. Okay. And that's based on the fact that our b value, our base, in this case is 2, it's greater than 1. Okay? If our b value is less than 1, so if our b value is 1/2, 3/4, 0.1, anything greater than 0 and less than 1, then we would actually have exponential decay, which would actually mean that this graph would be flipped across the y-axis. It would be mirrored. And so it would be coming down from the left, crossing the x-axis, or sorry, crossing the y-axis, and then trailing off along the x-axis to the right. Okay, so it would be like putting a mirror along the y-axis. Okay, which I think is the other one that they're asking you to do. And if you take a look at the values that they got in the solution on page 31, I think you'll see that it's actually mirrored. The negative values of x give us a positive y, and the positive values of x give us a negative y, exactly the mirror image of what we got for the 2 to the x. Okay. And oh, look at that! They even have the graphs down below. Okay, it is worth it to go through this at least once, so that if you're asked to plot something, you'll be able to do it. And being able to do this quickly is just a matter of practice, reasonably quickly. I don't know how long did it take? 10 minutes to do that. Okay. So then the next question they asked you is something about how are the graphs similar or different? Well, I already talked about that. They're mirror images, aren't they? Okay. And you know what? I think we actually pretty much, it's a relatively short unit here, lesson. But let's take a look at the support questions. Okay. It says, which equations represent exponential functions? Okay, now this can be tricky. Remember that our exponential function is going to be a times b to the x, or to some variable. Okay, so we need to have a number that's not 0. Okay. We need to have a base that's greater than 0, and we need to have a variable for the exponent. Okay. Now, let's take a look at a, 1a. Y equals x squared. Is this an exponential function? Okay. There's a couple of things against it. It does have, if we wanted to say what's our a value, it's actually there, it's 1, right? What's our b though? Our b is x, that's not correct, right? The b has to be a number, okay? So we know that the a is not an exponential function, okay? All right, well, let's try it with 1b. V equals 4 to the power t. Okay, so let's see. Our a value, again, is going to be 1. Our b value is going to be 4, which is, we want a number that's greater than 0. So that's correct. And our exponent is t, and that is a variable. So indeed, that is an exponential function. Okay. If you plotted that for different values of t, you would find it takes one of the shapes. It actually takes an exponential growth shape. Okay, and we know that because the b is greater than 1. Okay. All right, well, how about c here? This is going to be interesting. So it's 1.05 to the power x. So our a value here is basically 1, okay? Because we could rewrite this, y equals 1 times 1.05 to the power x. Okay, our b is 1.05, which is a number that's greater than 1, and indeed the exponent is a variable. So that is, there you go, that is an exponential function. And because our b value is greater than 1, it's also exponential growth rather than exponential decay. All right, so question 2a, they're going to ask you to do a table of values, y equals 5 to the power x, and then y equals 1 over 5 to the power of x. Remembering what happened when we did the one with 2.5, you might be able to take a little shortcut there if you're going to make that table of values. And again, I'd suggest -3, all the way up to 3. In case you're wondering why I started with -3, by the way, it's usually, it's a, let's take a look at our table. Whoops, take a look at our table here. They start with the negative value, and it's actually, might be hard to see, but it's actually numerical order. We're going from lowest to highest, right? It's pretty obvious we're going from lowest to highest when we start looking at 0, 0, 1, 2, 3. But it may be a little less obvious if you're going to do when you start with negative numbers. Okay, and I've lost my place completely. Oh, there it is. Okay. And then it says how are the values in each table related, and then graph the functions. How are the graphs related? Okay. Now, a question like this, I'd mentioned it before, and since we do have a little bit of time here, you can always use Microsoft Excel to do something like this. And if you were doing this as an assignment and you handed it in Microsoft Excel, just print it off or something, I'd take that, no problem. So I'm just going to show you how I would do something like that in Microsoft Excel. Okay. So we're going to start up Excel here. And Microsoft Excel, you can type your y equals. Now, this is going to be interesting because it's kind of tricky in Microsoft Excel to, I think we have to go into the font menu, and we can ask for an exponent. I don't think it gives us exponents though. No, it doesn't. So what we do is when we're using exponents in the computer, we use an up arrow, which is a shift 6. Okay, that's our way of saying that is 5 to the power x in the computer. Okay. You may have seen that written before. So you can format these things, and that's your headings, right? So let's say that we want to make from -5. Since we're on a computer, it doesn't really matter, right? So we want to go from -5 all the way up to +5. I'll give you a little shortcut here. Notice that Excel is actually pretty smart. If you start making a table of values, um, oops, you select two of them, and then you pull it down. You'll notice that it has a little -3 there, and I'll just keep going until we get to 5. See, if you just put two of your values in, it figures out that you're trying to make a list. Okay. Now, we need to type in y equals 5 to the power x here. So the way you do it in Excel, you start with an equal sign, which tells it that you're going to be making a formula, 5, and then we use that up arrow. Now, but we're not going to say x. We got to click on this cell over here, and notice it puts A5. See, it's A5. So what we're saying is this is equal to 5 to the power whatever is in A5. And then you hit enter. And notice it calculates it for you. Now the problem here is that it calculates this is actually a fraction, right? It's 1 over 5 to the power 5, which is 25. But it just makes it as a decimal number. But that's okay. So now what we do, we don't have to type anything else. I'm just going to copy this. So I'm going to go here. I'm going to do copy. And I'm going to select all these cells. And I'm going to do paste. And now what it's done is it's put all that data. It's copied that formula, but it's changed the x value to be the one right beside it for each one. You see, it knows that we want to use a different x value for each row of the table. Okay. Well, that's not so bad, except that it's kind of we lost our fraction format here. But here's what we gain. What I'm going to do here, I'm going to select all of our data, including the headers. I'm going to go to Insert, and I'm going to go Chart. Let's see. I want to make a scatter chart with curves, I think is what I want, with points. You can try different things, you know. If you don't like what it gives you, then you can change it. Well, that's actually pretty good. It's not so bad, eh? So this is what our chart looks like, and because we selected everything, it seems to be, yeah. I think we did all right. Now, the scale is kind of it's really hard to see the smaller numbers because it all looks like they're right on the x-axis, but they're not. They're just very, very tiny numbers. Okay, but you see the exponential growth here. See? Well, let's say that we wanted to make this so that there were fewer numbers. We could do that. I'm just going to take the data, and what I'm just going to do, I'm going to cut a couple of them out. So now we have a smaller range of values, and I'll go up and we'll do insert and we'll get a scatter chart and we'll do another one. Oh, look at that. Okay, so that looks a little better. Still kind of hard to see the small numbers, but you get the idea, right? Well, here's the power of this thing. Okay, the power of this thing is that now that we've done this, I'm just going to go copy this data here. Now that we've done this, I'm going to change this to the other question they had, which was 1 over 5. So 1 over 5 to the power x. I could have just changed it to negative x, but this will work. And now I'm going to change that one formula. And it's just going to be 1 over 5. And now I have to copy that formula and paste the change into all the other ones. So I'm going to go copy. I'm going to paste that in all the other ones. Paste. There you go. Okay. And we'll go up, insert, scatter chart. And so with very little effort, we were able to just change this, make a new table, and come up with a different formula, right? In fact, if I now, like if I did that and then I look at my key question and I see they're using 4 to the power x, you know, it would be pretty easy just to go and change this to be 4 instead of 5, right? Okay. So that's why I like Excel. It's a really handy program to know and to learn. And Microsoft themselves, if you go to the Microsoft website and do a search for Excel training, and they have some great videos that you can watch to take you right from the very beginning of Excel, and it probably doesn't take you very long to learn how to use it. So it's a really good program for any math student to know how to use Excel. Okay. So let's see, where am I going to put this now? Okay. Sorry, don't mind me. I'm just going to be clicking around here. All right. And so this is Q1 for SQ2. Okay, just in case I want to be able to show that to someone. All right. So that's pretty much the key question, or you know, it shows you how to do the key question for this particular assignment. We already did if we take a look at key question number 5 on page 32, we have, it just says which equations represent exponential functions. So remember our criteria is that it's going to be a times b to the power x. A has to be not 0, and b has to be greater than 0. And they both have to be numbers, okay? And then this has to be a variable. Okay. Okay, and then make a table of values for the following. So you could do that, and we're using 4s there. So you know it wouldn't actually be -4, 0, +4, 8, -8, something like that. I'm not, you might even just, instead of the 8, you could do -2 and +2 instead. Might actually give you a good shape of your graph. Okay, so it's worth doing that. If you want to do it in Excel and fool around with that, you're certainly welcome to. Okay, and then it's just going to ask you the same questions that they asked in the key questions. Wow. So look at that. We are at the end of Unit 1, and we've pretty well done all of the work in Unit 1. Okay. So go ahead and get your key questions sent in. It's kind of it's really good to kind of keep track of, you know, keep on track with the course. You don't want to wait too long to do those key questions, because they'll you know, you maybe sort of get mixed up with the new material, and the quicker you do the key questions, the quicker it reinforces what you learn. Okay? All right, well, what we can do here, whoops, sorry about that. Let's just go back a little bit and review Unit 1. I don't really want to look at Unit 2 right now because it's new material, and you know, we just we're going to save that for next week. Okay, let's go back and take a look at the topics that we covered here in Unit 1. We come a long way here. Okay. So the first thing we looked at was sort of the basics of algebra. Okay. We looked at the vertex form, which is different from standard form. So, you know, one of the things we haven't done is done any kind of conversion between vertex form and standard form. If you ever take a class like this again, the grade 12 version or college, I'm sure that they will show you how to go from vertex form to standard form and back again. Okay, it's a pretty standard thing. But having said that, as long as you recognize standard form and vertex form, so vertex form is going to be y equals a times x minus h to the power 2 plus k. And the nice thing that vertex form gets us is that the h and the k tell us what the vertex is of the parabola. So that's the highest or the lowest point. Okay. So when we started way back 2 weeks ago, we started looking at the vertex form, and we looked at what the effect of the A, the H, and the K were. And we found out that the A determines whether the vertex opens, or sorry, whether the parabola opens up or down. Okay, so, and if A is positive, it opens up. And if A is negative, it opens down. And that's really about all A does. A also determines the width of the parabola a little bit, but it doesn't really, we don't spend a lot of time looking at that. Okay. Now, the second one, the one that was maybe a little bit confusing, is the H. Because the way that the text talks about H is they're assuming that H is substituted into the standard form, which includes a negative sign. Okay, and basically the rule is that if you see a negative sign, oh, okay, I meant to have a different color there. If you see a negative sign, x minus something, you know that H is positive, and the parabola shifts by 8 units to the right. Okay, and if you see a positive sign, you know that H is negative, and it means that the parabola shifts by 8 units to the left. Okay. Okay, so for example, when they're going to show this solution here, this is on page, where are we? Page 8 of Unit 1. So A times x plus 3 to the power 2 plus k. So because there's a plus sign here, we know that the parabola shifts 3 units left. Okay, or negative 3 is basically what it is on the x-axis. Okay, and indeed, it's just 3 units left if we plotted it out. Okay. All right. And then the k wasn't really, it was pretty straightforward. The k just shifts up or down by the value of k, right? So if k here is plus 5, it shifts up 5 units. If it's negative 5, it shifts down 5 units. Okay, so that's pretty straightforward, right? So if you've not really sure about doing those key questions, this would be a good place to start. Okay, and actually I think I did quite a few of those, didn't I? Actually I think I showed quite a few of them. Okay, so give those a try. I encourage you to try them, and if you're not really sure, you can just, do a few of them and take a picture of it or fax it to me with a little note saying, can you please look at these? Okay, so, and it doesn't have to be a big formal thing. You can actually send me your whole assignment. I'll mark it. I'll send it back. And if you don't like your mark, if you there's some that you didn't know how to do, some you got wrong, redo them and send them in, and I will fix your mark. Okay, that's the way it works here. Okay, so if you can keep sending it in until you get the mark that you want. Okay. All right. So that was key question number 1, and there's quite a few here. Something like this with question number 7, a word problem. I encourage you to give it a try. A diagram is a must, and in fact, whether you get the answer right or not, if you have a diagram, you'll get a few marks for that. Okay, because it kind of shows that you are trying to use the problem-solving techniques, okay, and you're trying to understand the situation. So I drew what I thought this thing looked like, where somebody's diving off a cliff, and it's a parabola, and you know, question 7, it turns out to be, maybe once you draw a diagram, it's maybe not quite as tricky as it seems. Okay. So that was key question number 1, lesson number 1. Lesson number 2, we were just learning about the distributive property, and, or a law as they call it, and how to multiply two binomials together. A monomial by a binomial, which is example 1 here on page 13. Okay. And you know, how we distribute something that's sitting in front of the brackets. And it's also important, if you have a negative sign instead of a number, to understand that that's a -1, and you just apply the same thing. We were also working on understanding what happens when you multiply two signed numbers together, or two signed variables or whatever. If the signs are the same, the answer is positive. If the signs are different, the answer is going to be negative. So the way I teach it is to work out the sign first, and then write that down, and then just multiply the variables or the numbers. Okay. Now we use FOIL, front, outside, inside, last, to help us keep track of how we're going to approach multiplying two binomials together. So something like, not this actually, something like this, page 14, right here. Okay, so we're just going to do it one step at a time. Now, when we're multiplying binomials together, what tends to happen is that the middle two terms need to be combined. So we have a step called combining like terms. Okay, and like terms in our case means that they have the same variable or combination of variables and exponents. Okay, for polynomials of order 2, so ones that have a square in them as their highest exponent, they tend to only have those two in the middle. Okay, you're gonna take the next step in this class, you'll probably be dealing with trinomials and you're dealing with equations that have cubes and exponent 4s and stuff like that, and then there'll be more combining of like terms. Okay, now so when you're going through and you're reviewing, make sure that you look at the support questions and sort of understand what they're talking about, expand and simplify. As far as I'm concerned, that's just multiplying them together. I consider that to be one step, because you can't really just multiply using FOIL and then not do anything. That there is a step, which is to combine like terms, which is what they are calling simplify. Okay, so give a few of these a try, especially the weird ones like this. Look up the answer in the back of the text or in the back of the unit, and see how you did. Okay, and again, then you can send in your work. You can send in the key questions one at a time. I know some students like to kind of save the whole thing and send in the whole unit. The problem with that is if you're on the right track, it works great. But if you're off a little bit in that first unit, the first lesson, then it can kind of be a problem, because you'll be making the same mistake all throughout. So as long as you're confident, it's fine, but feel free to just send in one key question or two key questions for marking, and then you'll be sure to get the most marks possible. Okay. So I think that's going to be it for our review. So on Tuesday, not Monday, on Tuesday, let's come back and make sure you get your Unit 2, and we'll start Unit 2. All right. Well, thanks for joining us. Have